In this unit, we will talk about programming languages. A programming language is an artificial language that can be used to control the behavior of a machine, particularly a computer. Programming languages, like human languages, are defined through the use of syntactic and semantic rules to determine structure and meaning, respectively. A prominent purpose of programming languages is to provide instructions to a computer. As such, programming languages differ from most other forms of human expression in that they require a greater degree of precision and completeness. When using a natural language to communicate with other people, human authors and speakers can be ambiguous and make small errors and still expect their intent to be understood. However, computers do exactly what they are told to do and cannot understand the code the programmer intended to write. The combination of the language definition, the program, and the program's inputs must fully specify the external behavior that occurs when the program is executed. Many languages have been designed from scratch, altered to meet new needs, combined with other languages, and eventually fallen into disuse. Although there have been attempts to design one universal computer language that serves all purposes, all of them have failed to be accepted in this role. The need for diverse computer languages arises from the diversity of contexts in which languages are used. The first programming languages predate the modern computer. By the beginning of the 20th century, punch cards encoded data and directed mechanical processing. The computers of the early 1950s, notably the UNIVAC 1 and the IBM 701, used machine language programs. Machine language programming was quickly superseded by assembly language programming. Later in the 1950s, assembly language programming, which had evolved to include the use of macro instructions, was followed by the development of three modern programming languages: Fortran, which was developed by IBM in 1954 and was used for scientific and engineering applications; Lisp, and COBOL, which stands for Common Business-Oriented Language, and it was developed in 1959 and was mainly used for business applications. Updated versions of all of these are still in general use, and importantly, each has strongly influenced the development of later languages. At the end of the 1950s, the language formalized as ALGOL 60 was introduced, and most modern programming languages are in many respects descendants of ALGOL. The period from the 1960s to the late 1970s brought the development of the major language paradigms now in use, though many aspects were refinements of ideas in the very first programming languages. In the 1960s, Simula was the first language designed to support object-oriented programming. In the mid-1970s, Smalltalk followed with the first purely object-oriented language. BASIC was developed in the 1969 and was widely used in microcomputer programming because it was very easy to learn. Visual Basic is a modern version of the old BASIC language, used to build graphical elements such as buttons and windows in Windows programs. Pascal was created in 1971. It is used in universities to teach fundamentals of programming. C was developed in the 1980s at AT&T. It is used to write system software, graphics, and commercial applications. C++ is a version of C which incorporates object-oriented programming. The programmer concentrates on particular things, such as a piece of text, a graphic, or a table, and gives each object functions which can be altered without changing the entire program. For example, to add a new graphics format, the programmer needs to rework just the graphics object. This makes program easier to modify. Each of these languages spawned an entire family of descendants, and most modern languages count at least one of them in their ancestry. The rapid growth of the Internet in the mid-1990s created opportunities for new languages. Java was designed by Sun Microsystems in 1995. Java programs, called applets, provide animation and interactive features on web pages. Java is an object-oriented language similar to C++, but more dynamic and simplified to eliminate possible programming errors. Java is both compiled and interpreted. First, the source code is compiled and converted into a format called bytecode, which can then be executed by Java interpreter. Compiled Java code can run on most computers because there are Java interpreters known as Java virtual machines for most operating systems. Java is multi-threaded, meaning a Java program can have multiple threads, that is, many different things processing independently and continuously. This enables the program to make the best use of CPU power. Most programmers like Java because it allows them to write applets which make web pages more interactive and attractive. A web page that uses Java can have sounds that play in real time, music that plays in the background, cartoon-style animations, real-time video, and interactive games. The Java Micro Edition platform is used in mobile devices. It provides flexible tools to create applications that run on mobile phones, PDAs, TV set-top boxes, and printers. Nowadays, most phones are configured to use Java games. One alternative to Java is Microsoft C#, a .NET language based on C++ with elements from Visual Basic and Java. There are no substantial differences between C# and Java. When software developers do measurements on pieces of code, sometimes Java is faster, sometimes C# is. Another competitor is Adobe Flash technology, which supports graphics, a scripting language called ActionScript, and streaming of audio and video. Flash is used to create animation and advertisements, to integrate video into web pages, and to develop rich internet applications such as portals. Flash files, traditionally called Flash movies, have a .swf file extension. They may be an object on a web page or be played in the standalone Flash player. Each language is designed for use in solving particular types of problem and therefore has particular strengths and weaknesses. A system analyst has to decide which language is most appropriate in each situation. Languages such as C++ are particularly suitable for writing system programs. Language such as Visual Basic is easy to use and is particularly suitable for learning how to program. Fortran is designed for solving engineering problems. COBOL for writing business programs. Ada for military purposes. Prolog and Lisp for working in artificial intelligence. Programming language evolution continues in both industry and research. Current directions include security and reliability verification, new kinds of modularity, and database integration.